All right, hello, whoever's watching this video. We are starting and doing 2.9 today, and this is the last section of the chapter, so here we go. We are doing absolute value stuff it says by graphing. I don't want to graph it. Solving is a lot easier. We're going to relate it back to the graph, but that's not how I'm going to solve these. Can we do that? We don't like to graph, okay? So we're not going to graph, we're going to relate it back to the graph, but that's not going to be the sole reason or the sole way that I find the answer to this, okay? So when we are solving by graphing, or when we're relating it back to graphing, if we have an absolute value looks like a V. Have we talked about that before? Yeah. Absolute value. So like the absolute value of X, he is, maybe put this off to the side, he is a V going out straight at 45-degree angles, just like that. Y equals the absolute value of X. That's what he looks like. Is a V straight out at 45-degree angles, okay? Which really makes a 90-degree angle here in the middle. It's like a perfect corner there, okay? So what we can do is we can move that absolute value down a little ways, and when I do that, he's going to cross the x-axis at two places. I have two solutions, right? Two answers, okay? Then this one, where the vertex is on the x-axis, he's going to only have one place where he touches, or one solution, one answer, right? And then this one has no solutions because he's not touching at all. Now, let me give you a scenario of when this would happen. Let's say I have x minus 3 is equal to -4. Now, you could try to solve that if you want to all day long, but...
Oh, it can't equal a negative.
When you're taking the absolute value of something, it always turns everything positive, true? Yeah. Okay, so can you have the absolute value of something be equal to -4? No, so that would be a scenario where we don't have a solution. There are no answers that I can plug in for x and have it come out to be a negative because we're taking the absolute value. We're starting. All right, good? Yeah? All right, let's move on down. Let's do a problem here. I'm going to not solve this by graphing. We're going to actually solve the thing, okay? All right, so I want to do some stuff first. If we're given just this, what would you like to do first?
Subtract the 5.
I'm going to subtract this 5 from here over to the other side, right? Okay, 5 will be gone. So I'm going to write my work over here. If I subtract that 5 over, I have 2x plus 6, the absolute value, equals 0. Can you have an absolute value equal to 0? Yeah, just not negative, right? It can't be equal to a negative. Okay, now do you remember what we do as soon as we get an absolute value by itself? We do two solutions, okay? Well, we'll talk again why we do two solutions, okay? The first solution, I just take 2x plus 6 equals 0. I just get rid of these bars right here and I just solve from there, okay? The second thing that I do is negative 2x plus 6 equals 0. Okay, got it? When I have an absolute value, I have to consider both parts, because if I take the absolute value of this chunk, are you guys watching me? Yeah. Absolute value of this chunk, is that going to be the same as the absolute value of this chunk?
No.
Sure, because it's going to get rid of the negative. When you take the absolute value, it gets rid of a negative, right? Mm-hmm. So those two things are equal to each other in absolute value land, all right? And then we just have to solve. So over here, if we subtract the 6, 2x equals -6, and then we divide by 2. Wait a second, we got -3. Can you get a negative number as an answer?
Yes.
Sure, yes, you can.
Yeah.
Sure, you can, but you just can't have it set equal to negative over here, right? You can plug in a negative into an absolute value, but the output value, whatever you get on this side, can't be a negative. Make sense? Okay,
Yeah.
Good. I'm glad we cleared that. All right, now, what do you want to do to this thing?
This thing is -2x minus 6.
Yep, let's distribute the negative through. So -2x minus, we really have.
What is the difference between this and like what we've done?
Because we're going to talk about, because here we're only going to get one answer. And I'm going to tell you what that means, right? We're going to talk about what that means.
Only one
Okay?
of them is going to work?
Mm-hmm. Well, no, not one's going to work. If we add the 6 over, we'll just see. -2x equals 6, and we divide by -2, and we divide by -2. Oh, wait a second. We got -3, which is the same thing as what we get over here. So why do we only get one answer? Why do we only get one answer? Why do we only get one answer? X is -3. That means he's doing something like that. He's only touching at -3.
And 0. Or does 0 not count?
Well, it's negative 3 comma 0, right?
This guy touches X
Okay,
at
but he's only going to
7
touch
and
the
negative
X at negative 3 and not anywhere else. Got it?
-4.
Okay. What?
This guy.
He doesn't go down and then come back up. He just comes down, touches at negative 3 and goes back up from there, right? He's not going to go below the x-axis, okay? So that's why we only get one solution there, all right? Okay, good? Happy with that? They wanted to graph the whole thing. I'm not going to do that because that is slowing us down, okay? I'm using the graph to solidify what we got as an answer, right? Like to make sense of it, but I'm not going to solve it by graphing. I don't want to do that, okay? All right, let's go down to example 2. Go to the back side, go to example 2, please. This one they want us to graph it using a graphing calculator. I don't want to do that either. Okay, so focus in on this problem. This is example 2, and let's do some things. What would you like to do first?
Add the 8.
Kind of.
Or divide.
Subtract the 8.
Yeah.
Yeah? Yeah, that's what you meant. I know what you meant. Okay. All right, so we still have the 4/5 out in front. X minus 1 whoop, whoop, equals how much?
I don't know.
3.
3 equals 3. Okay, now what?
Divide by. Or multiply by 5.
Divide by 4/5. Okay, and rather than dividing by 4/5, we can
Multiply by 5.
times 5 over 4. Okay, so I'm going to take it times 5 over 4. Ooh. So x minus 1
15/4.
equals, what's 3 times 5 over 4?
15/4.
Yep, this is like 3 over 1 times 5 over 4. So it's 15 over 4. Ew. 15 over 4 is 3.75. Let's go ahead and do it as a decimal because it's easier to see that way. 3.75. Let's do that. Okay? That's what he is. All right, now what do we do?
X equals.
Split them up. 2 cases. 1 over here, 2 over here. X minus 1 equals 3.75. Okay? Over on this side, we get negative x minus 1 equals 3.75. If you want to go ahead and distribute your negative through, that's fine. You can do that. Okay? Here, if we add the 1 over, we get x equals what?
X
4.75.
4.75, okay? And here, if we distribute our negative, we get negative x plus 1 equals 3.75.
So the exact same thing? No.
And we're going to subtract 1. Negative x equals 2.75, but then we have to
So it's x equals negative.
divide by negative 1, so x equals negative 2.75. Okay, so what happens here? We got-
It's the point. It hits the x.
We got 2 answers. He's going to touch at, here's 1, 2, 3, at 2.75, which is here. And he's going to also touch at 1, 2, 3, 4, 5. He's going to touch right here at almost 5. So he's a V that looks like, I don't know, like this. Beep, like that. Ugh.
Can you also be
Pretend
more
that looks
shallow?
nicer. Pretend that looks nicer.
Can it be more shallow if you want it?
Yes. So like me be narrower? Yeah. So he could go down like a long ways. Or he could be like really short and fat, right? So maybe he's like here. Maybe he's actually doing this. Is that what the graphing calculator makes it look like?
Yeah.
Hey, there you go.
No.
Okay. And we don't know that. We don't know that at all. We just know that he's touching at those places. So, I mean, for all we care, it could be a short, fat one. Or it could be a tall, skinny one, right? We just care about where those points are located, right? Okay. Got it? Yep. So the graphing calculator makes it look like more like the purple one. Okay. But that is an example of 2 solutions. Got it? You just keep foiling it down until you get to the point where you have 2 cases. Okay. All right. Let's see what else we've got. I'm gonna guess if I was a betting person.
Whoa.
If I was a betting person, I would guess that this one is going to be no solutions, but let's see,
Why did you
okay?
guess that?
Because we've had 1 solution and 2 solutions so far, so I'm going to guess that this one has no solutions, but let's see. I don't know. I could be wrong, okay?
So is this
So-
like what we're doing on our homework film?
Right.
So
Yeah.
literally the exact same thing that you have on your
Basically, yeah.
So what if
You
you're
already
just
know
saying
what
like how it is?
How it relates. Yep, back to a graph.
It
Okay,
is-
so if you're given this guy, what would you do first?
Subtract the 9.
Minus a 9, minus a 9. Okay, 14 minus 9 is
5.
5. I'm skipping down to this step because that's what they've done, okay? Then we divide by negative 3. Okay. Negative 5/3 is what that is, or like 1 2/3, right? Or 1.6 repeating, right? Okay. Now at this point they stop. Why do they stop? Why is this no solutions? Can you have an absolute value result in a negative number?
No.
No. So this is never true. Okay, because the absolute value of a number is always positive or 0, we can get it to be equal to 0. This sentence is never true. The solution is no solutions. You can do a circle with a line through it or no solutions, okay? So let's talk about what this means. Whoop. Let's talk about what this means. Huh. It is either up here or, in this case, it is not up there. The whole absolute value has a negative in front of it, which means he is actually pointing down, which means he has to be probably more like that. Okay, does that make sense? So he is the pink one instead of the yellow one, right? If he has no solutions, he's either entirely above or entirely below. This one's entirely below because he's negative in the front. Got it? Okay, what else we got? Oh, by graphing. Okay, here we go. We are going to, oh, heavens. I don't know if I want to do this.
No, we don't want to.
Yeah, well, we're going to solve it, though. I don't want to do it by graphing, though. Nope, not going to do it by graphing. All right, here we go. Let's do this one. Here's my piece, and we got to do something first. What would you like to do first? Plus the 6 over. Yep. So now we have absolute value 3x minus 9 is less than or equal to 6. Perfect. There we have. Okay. Now what? Now what do I do?
You split it.
We split.
Yeah.
We split it. 3x minus 9 is less than or equal to 6. Okay. And the next one is negative 3x. Whoop. Minus 9 is less than or equal to 6. Okay. All right. Now let's add the 9. 3x less than or equal to 15. And divide by 3. What do you get? X is less than or equal to 5. Okay, on 2 over here. If we distribute the negative through, negative 3x plus 9 less than or equal to 6. Okay, then what?
Subtract the 9.
Minus the 9, minus the 9. Okay, negative 3x is less than or equal to negative 3. And then what?
Divide by negative 3.
Divide by negative 3. X is,
X is greater than or equal to
flip the sign because we divided by a negative. And that is 1 or negative 1?
1.
Positive 1. 2 negatives make a positive. So greater than or equal to 1, less than or equal to 5. Got it? Those are my 2 solutions. So he's touching at those 2 places. Okay? All right, now here's what this looks like if we graph it. At 1 and at 5. 5 is here, 1 is here, and he has a solid dot on those because he is equal to. So we have our V that's looking something like this, right? Okay? Now, as far as shading goes, because if he's less than, greater than, all that stuff, we have to shade. I want greater than 1 and less than 5. So am I inside of the V or am I around the V?
Inside.
You're inside. I'm greater than 1 and less than 5. So I'm shaded inside of here. That's how he looks.
Yay.
Got it? Make sense?
Yeah.
Yeah, that's not bad. We don't like tables. We don't like tables. We can do the algebra and we can graph. Okay? One more. Is there one more? Yeah, one more. Here we go. Let's do this guy. Okay, first and foremost, what would you like to do? Add the 3. Plus 3 plus 3. Okay. Now we've got absolute value. 5 over 7x plus 2. Are you guys following along?
Yeah.
Greater than 3. Okay, perfect. Split into 2. Case 1, case 2. You got to be very careful with your algebra. 5 over 7. X plus 2 is greater than 3. Okay? Then we have negative 5 over 7x plus 2 is greater than 3.
Yeah, minus.
Okay, you like to go ahead and distribute it through. All right, fine, whatever. Negative 5 over 7x minus 2 is greater than 3. That's fine. Okay, let's just keep solving him. Okay, add the 2. Negative 5 over 7x is greater than 5. Okay? Okay, now dividing by negative 5/7. Let's take it times negative 7 over 5. And take it times negative 7 over 5. So x is greater than. Oh, no, x is less than. Why? I was just trying to trick you. Ha. Okay. Sure. What does this become? 5 times negative 7/5. Negative 7. The 5's cancel, right? So -7. There we go. X is less than -7. Okay. All right. Now over here we've got subtract the 2. 5 over 7. X is greater than 1. Now we
Multiply it over.
take it times 7 over 5 because that cancels him. Times 7 over 5. X is greater than 1 times 7 over 5 is 7 over 5, which is 1 point.
7 5.
No.
No, what?
2 5.
2/5 is
4.
1.4.
Yay.
Okay. All right, let's look at our, do we have a graph? Oh, poo. They made it cheap. 1.4 is this guy right here, okay? -7 is this guy here. And he is a, what kind of line?
Dotted.
Dotted, because he's not equal to. So he is a dotted line. Dot, 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 dot. Dot, 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 dot. Okay. I want less than -7. If -7 is here, is he going to be this direction or this direction?
Wait, aren't those open circles not closed ones? Because it's not.
Oh yeah, correct. I didn't mean to make them like closed circles. Like that's just, yeah, open circle, open circle. Well, that's just helping me graph my line. My line is dotted. Blah, blah, blah. So -7 is this guy right here, and we want less than that. So is he going to be graphed to the right or to the left? To the left. So over here, and I want greater than 1.4, which is this guy. Greater than means over here. So he is shaded under and around, right? Not in between the absolute value. Okay? Not in the middle, but around the outside.
Macy has a question.
Yes, ma'am.
Never mind.
Okay. All right, there you go. That's it. Got it?
So, okay, wait. Do we just need to solve it?
You just need to solve it.
We don't need to do
You just need to solve it. No.
No.
No. Yep. So don't solve the equation by graphing. Just solve it using algebra. Okay? Got it? Got it?
I solved it using algebra.
Yeah, there we go. Okay? All right. Goodbye, people watching the video.